Moving an artificial intelligence from a passive chatbot to an active, autonomous agent breaks standard enterprise security models. Chatbots wait for inputs, agents execute tasks continuously, and the moment they burst out of containment, they bypass traditional security perimeters. The first critical failure mode of unchecked autonomy is a catastrophic expansion of the attack surface. If an agent is granted the ability to write and execute code without strict boundaries, it can easily initiate unauthorized internal network scans or execute arbitrary shell commands that expose sensitive infrastructure. Even if the perimeter is secured, autonomous agents hit a second severe bottleneck: context collapse. As an agent runs continuous tasks, it generates a massive, accumulating log of its own actions, errors, and observations. Because large language models have strictly fixed context windows, standard framework management relies on static truncation. This logic tree shows a standard agent processing those logs. When memory fills, the system chops off the oldest logs, causing the agent to instantly forget its instructions and shatter into disconnected pieces. The open-source framework OpenClaw was engineered explicitly to resolve these deployment bottlenecks. The 2026.4.8 release focuses heavily on stabilizing these long-running production deployments. The framework achieves this by relying on three architectural pillars: strict zero-trust security perimeters, a hardware-agnostic local execution model, and a state management system that mathematically mimics biological memory. Reliable enterprise agent autonomy requires these explicit framework-level constraints. Without dynamic state management protocols and hard operational boundaries, an agent cannot be deployed continuously in a sensitive environment. OpenClaw's baseline execution layer is built to run entirely as a lean Node.js process. It operates directly on everyday hardware rather than demanding specialized environments. Most production-grade agent frameworks require heavy, proprietary cloud infrastructure or expensive local GPU clusters just to host the orchestration logic, creating immediate lock-in. This diagram illustrates OpenClaw's decentralized compute model. The Node.js core handles orchestration, routing reasoning tasks to external API providers. This API-driven approach keeps execution costs tied to token consumption. You control compute spend locally without persistent cloud fees, maintaining low latency. To support this execution model, the 2026.4.8 release introduces a stabilized handling system for bundled channels, managing all external framework communications. Previously, plugin compatibility issues disrupted multi-provider deployments. These stabilized channels now allow developers to execute simultaneous multi-platform agent runs across applications like Slack and WhatsApp without risking synchronization failures or timeouts. For enterprise environments behind internal firewalls, this release refines proxy support, ensuring external API connections remain uninterrupted. By decoupling the runtime from heavy infrastructure, the framework guarantees highly controlled, low-latency execution directly at the edge of your network, exactly where the agent interacts with your local systems. Placing an autonomous execution engine inside a corporate network creates immense risk. Execution privileges. A single operational hallucination can compromise internal systems through unauthorized lateral movement. OpenClaw neutralizes this risk by implementing a strict zero-trust perimeter, beginning with server-side request forgery, or SSRF, guards. The SSRF guard operates at the network level. If the agent attempts unauthorized network requests to internal infrastructure, like a 192.168 address, the framework blocks the action. However, the perimeter logic allows greenlit traffic to safely reach external API providers. When the agent does need to interact with the local system, the framework enforces a strict human-in-the-loop mechanism. Any sensitive shell command is hard-coded to halt execution. The framework automatically routes a mandatory approval prompt to a human administrator's chat interface, ensuring critical operations require explicit authorization before proceeding. The final defensive layer controls the agent's capabilities through explicit plugin allow lists. Administrators heavily restrict the available toolset by forcing the agent to load only pre-approved plugins. This guarantees the agent cannot spontaneously invent or execute unvetted code pathways in a live production deployment. These explicit zero-trust boundaries are exactly what transform a vulnerable automation script into a highly secure, fully production-ready enterprise autonomous agent. A secure agent still needs to manage its own history to function continuously. The challenge is maintaining multi-session context, ensuring the agent remembers its operating rules without overflowing its token limits. Standard frameworks rely on vector database retrieval, pulling in unedited logs based on keyword searches. OpenClaw resolves this through a memory dreaming architecture, which mimics human cognitive consolidation to filter information automatically. This visualization represents an agent's raw, unoptimized short-term context. Every action, error, and response is recorded here, filling the window with chaotic noise. Developers control this clutter using the recall decay rate. Short-term memories gradually degrade and vanish as the timeline advances. This decay aggressively purges low-value noise from the system. By explicitly forgetting irrelevant details, the framework continuously frees up processing space within the active context window. For the information that does matter, developers configure a second parameter, the insight promotion threshold. This mathematical trigger identifies highly connected, recurring pieces of information. It elevates that critical context out of short-term storage and permanently anchors it in a persistent long-term memory vault. This entire consolidation process is powered by an operational mechanism known as dreaming cycles. Dreaming cycles schedule and execute this memory consolidation asynchronously in the background. The agent sorts its history and extracts insights without interrupting its active processing tasks. By mimicking biological memory, the framework creates agents that actively get smarter with use. They accumulate valuable institutional knowledge instead of drowning in outdated operational logs. Here is the complete OpenClaw architecture mapped out: a lean Node.js runtime core, surrounded by an SSRF security perimeter, and supported by a self-optimizing memory vault. This unified system powers end-to-end content publishing pipelines. Content studios use it to draft, schedule, and post material with minimal human input, safely routing outputs to external platforms. DevOps teams use it for orchestration. The agent automatically runs tests and executes code reviews, pausing at configurable human checkpoints for approval before deploying applications. In research and analysis, agents handle continuous market monitoring and automated data scraping, utilizing built-in retry logic to guarantee data retrieval reliability at scale. By prioritizing an open-source, hardware-agnostic model, OpenClaw avoids the trap of expensive, cloud-locked infrastructure that dictates how and where you can run your operations. Because the code is completely open source, the framework evolves alongside real-world developer needs, rather than being restricted by a closed-source corporate product cycle. OpenClaw 2026.4.8 delivers the ability to deploy highly capable autonomous agents securely behind your own firewalls, keeping total control over both your data and your execution environment firmly in your hands.